Welcome back, everybody. Today we're continuing to work on the Sci-Fi office project. We are building a cool custom handrail that goes on the edge of the mezzanine. This has been a long-term 2-year project, building all the components for this custom Sci-Fi office. So for this project, I'm bringing back my son, Jet. He's been helping me build this railing, and I want to teach him basics and then slowly make it harder as we go. In a previous video, I had Jet build simple sections of railing. You can go back and check out that video if you want to know how we did it. But today we're going to be building something much more difficult. And what we're building is a post. So what makes this post tricky is that we have 12 individual components that need to be tied together to make this one unit. Second thing, there's lots of angles and relationships between all these tubes that need to be correct. Why? Because we are going to be building 8 of these with components that tie into the rail and build off of it. So if these parts are welded incorrectly, it's going to have a negative chain reaction effect on the rest of the railing. We are going to be having CNC components fitted up to the sides of these posts, and we need this structural skeleton to be the reference for those parts. We don't want our post leaning to the left, right, back, or forward, so we need to have everything welded correctly. Even myself with 20 years experience would find this a little bit challenging. So I know with Jet's skill set that he would probably struggle along the way if I just turned him loose on having him build it. What I'm going to do is I'm going to help him cheat. I'm going to give him the fixture table, a map, and a little bit of guidance. And then of course, all the knowledge that he learned in the past video, he can apply to building this much more complicated weldment. With Jet's little experience, I want to have him have big success. And that's the goal of this video. And along the way, I want to walk you through on how Jet's going to do it. All right, Jet, so what I've made for you is a fixture map, just like we did last time in the previous video. Yeah. So the neat thing is I already have this catted out, and I'm able to put this down on the table so that we're not down here trying to fiddle with where do all the fixtures go. Yeah. So a couple things to notice when you're looking at this map, and you can double check me and yourself when you're doing this. So if you look at this right here, I have a part that touches each tube in 2 places. When it does that, it locates the part at the angle, and then the other components, when they come into the intersection, we have a little bit of freedom there. Okay. So this is one of the reasons why colleges and schools like this formula, is because there's a set of rules, and if you follow them, we can set up this system, and I can pass to you, and you can build it. Okay. So the first thing with fixturing right here is we want to give ourselves 3 or 4 fixed points on the table. And in this instance, they're going to be these 3 tower blocks here, here, and here. Okay. Okay. Now these are going to be locked into the holes of the table and they don't move, basically creating 3 points, and that's going to give us our reference system. Everything's going to be located off of those 3 points. The next thing we want to do is we want to build as close to the corner of this table as possible. If we were to build in the middle of this table, it's going to be harder to reach. Okay. Okay. So as we're welding, we have to be thinking about that. We have basically almost 2 profile frames, and then we're going to space them a certain distance apart, weld in those pieces that are going to hold out those 2 profile frames. Okay. What we could do is build this in 2D, flat on the table, one side, and make all our side frames. And then make a secondary fixture to stand them all up and weld those 2 frames together. That's just gonna take more time. What's gonna happen is we wanna set up a fixture to where we can do it all in one. So this little fixture placement I have for you is gonna allow us to build all the 2D frames and then the 3D frame when we're all done. Okay. Without having to reset anything up. So Jet, what I want you to do is start following the map. I want you to grab the 3 tower blocks and start putting them in their correct location. Remember, like in the previous video, you have your grid system. Yep. So follow the ABC and locate them on the holes. Start placing the pieces where they go. All right. Okay. So as Jet's doing that, let's talk a little bit about fabrication methods that I'm used to. So Jet has a really cool opportunity here. I started off fabricating where I would go and cut my material to the length of the part that I was trying to achieve or build, and then I would use the material to set the next piece of material. So if I cut this to length, let's say this was 8 inches, I would use this material to set this distance, and I would continue to go around and use that to set all my parts. So this part is referencing off this part's referencing off this part, vice versa. And then I would tack it all together, square it all up, tap, 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 measure, 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 and hopefully get it all right. But now, with a fixture table and with a map, I don't even need to use my material for reference anymore. I could set up my desired shape first and use the CNC to grid holes because they're perfect and set up my desired shape. No matter if it's at an angle like this, I can set up a desired shape using the grid pattern on the table and not have to use my material. Why wouldn't you want to use your material to set up relationship with other parts? Well, there could be errors in material cut. If I have to pull a tape measure out, I couldn't measure measure wrong. So there's a lot of variables with doing it the way I was taught originally. That's why this is really powerful. Jet's gonna set all the fixtures up, and then the material is gonna conform to the fixture, not the other way around. All right, Jake, looks good, got your blocks set up. Here's the next problem. We got this nice straight piece in here, which is gonna reference off of these blocks, but now the other 1, 2, 3, 4 components are all at weird angles, and they're all weird on the table, which means they don't fall on the grid, as you can see. When I used to have to do this, I used to have to grab this protractor right here to locate this tube. You gotta set the angle, and then off of this tube that I hopefully got right, I'd reference this tube, and then off of this tube, I'd have to reference this part. And as you can see, the chain of events, I could eventually maybe add some errors into there. You don't have to do any of that.
Fixtures do it for me.
Fixtures do it for you. In CAD, I'm able to tell you where this angle is, where it's placed in relationship to this tube on all 3 parts. They all have their own home position without you having to even pull out this protractor. So as you can see here on this map, we have a 105-degree angle, we have a 120-degree angle, we have a 135-degree angle, we have a 110-degree angle.
Okay.
Right? It's a little overwhelming.
Yeah, a little bit.
It is overwhelming, but this is why this system is very teachable, and it's why you're going to be able to set all these parts up and put them in the right place. So if you look at our block and another drawing, we need to be able to get up to at least over 10.5 inches tall. And the neat thing about the tooth block is that it's modular, and we can exchange this short riser for something much taller.
Okay.
You're gonna convert all of these tooth blocks into tall risers, right?
Yeah.
Okay, let's do that first.
Okay.
So as Jet's setting up the tall risers, let me show you how they go together, in case you've never seen this before. So you have a tooth block. This is a slotted fixture that goes on the table. So this is like the chassis, the base to the entire fireball system. Now if you notice at the end of the slot, there's a hole and 2 little fastener holes on the side of it. This corresponds with the bottom of the riser, also has a large hole and 2 little threaded holes. So what we do is we thread the peg into the bottom of the riser. This is what gives it all its strength. We can do finger tight, or at the bottom of it there's a little hex there. Snug it up with the screwdriver. Make sure it's clean of any yuckums, sawdust, grinding dust, and then we mate them together like that. But as you can see, it turns and they're loose. But what we do is we use these little socket-headed cap screws, put it in the hole. I get fairly snug, and then I just make sure that it's kind of straight true. Make sure it's all centered up there, just like that. Converted that into a tall riser. Pretty slick. You guys don't need to be intimidated by this system. If a 15-year-old can do it, I think anybody can. So Jet's gonna start following the map and placing our tall risers around the table. As Jet's doing that, I'm gonna walk you through what he's doing. So on the fixture map, what you have is a drawing that tells you the grid of the first hole that these fixtures are being placed in. So a good example of this is this tooth block right here is in row C. Grid line 2 is the first hole. This washer goes in the hole like that, gets set with a pin, okay? And this is all the way back to 0. You can see there's no extension there in between the tooth washer and the block. And then the map tells you how far out to extend the block. And in this case, it's 1 11/16. If you look at our tooth washer here, you can see it has an 1/8 of an inch on the side of it. But this washer isn't going to work because we need to be on 16ths. So what we do is we get a washer that sets our dimension to 1/16. So everything from 1/16 to 11/16. If it has a 16 after it, you're gonna use this washer. And what it's doing, if you can see, is the teeth are offset 1/16 of an inch. The high and the low and the high and the low of these 2 washers don't match. And that's how you get the 16th of an inch. Now, this is less confusing system because you can just look at it and know that you're at a 16th or an 1/8 of an inch. I can clearly look at Jet's fixtures and know if he has the right setting just by looking at the washer underneath. If this was a reverse type thing where you got to flip it around or upside down or backwards, there's possibilities of screw up, and we're trying to remove screw ups from this process. Okay, so back to 11/16. We'll put the right washer in there, which is a 1/16 of an inch. We would put this on the front pin, and then we would lift this up and slide and extend it out 1 11/16. 8, 9, 10, 11. And then I would lock it down, and that's what Jet is doing all along this entire table. And then we'll use a second pin in the back to prevent it from pivoting, okay? This pin doesn't have to be a lock, it's just a anti-rotational pin. And the idea behind these teeth that are in here too. Not only does it locate the block in the right spot, but it prevents it from moving backwards. So no matter how hard I hit this, bump it or move it, it cannot slide back. What you don't want to happen is this gets bumped and moved out of position, or when you're fabricating, you're gonna have some welds pull and you want this piece to stay in the right spot. So another common question is, why is the washer underneath? Can you put the washer on the top? And the simple answer to that is absolutely yes. You can configure it this way if you want to. It means you have to lift the washer up with your hand, slide it, which is convenient sometimes, but it's two-handed operation. The other negative to this placement is that these teeth are now exposed, which could lead to spatter getting in there or something falling or dropping on it. My personal preference is to have it flipped upside down. If I have the bolt loose enough, I can lift the tail up and slide it like this, and it's a one-handed operation. And it protects the teeth from getting spatter or damage. But absolutely, you could have it operating upside down if you want to. The riser can be mounted on the bottom or flipped over, whichever way you prefer. There's no right or wrong way to do it. It's personal preference. So here's another cool thing about the tooth block is that you can see we got a tall riser on here, and let's say you have a lot of weight you're gonna put on the riser by attaching something to it, and you're a little worried that this might deflect a little bit. Well, what we have is a cool trick up its sleeve. We can add a stiffener in between these 2 points by using another tooth block. We'll thread it in the back of the blocks, and then we will go riser. This is a 6-inch riser. Then we can put a screw in here, and we use an extra tooth block. We put it in the hole like that. We can use 2 pins. We can lock it down. So the neat thing about this setup is you can reuse parts that you're not using in your kit. So now we've backed it up and made a really strong fixture with it.
What kind of scenario would you use this in?
Something like this.
Yeah.
If I was hanging something really heavy off the front, or if I wanted another sliding block up here, right? Another extra riser to go off the other way. Really, the sky's the limit. It's a big, huge erector set. And that's why I really love this modularity compared to the other fixtures of other table companies. They don't allow you to do stuff like this. All right, Jet. Sure that one's in the right spot? I don't think that one's in the right spot.
Sure.
Doesn't look like it. Shouldn't that be that far forward? Look at your map. As a foreman of this plan or this build, I'm able to quickly look over Jet's progress and go, if something doesn't look right, and I can tell that this fixture.
This one's right, this one's wrong.
There you go. So one of the things I've noticed about working in the trades is that there's no plan when it comes to fixturing like this. Me as the foreman doesn't know what the welder's doing. But now if everybody's trying to follow the same blueprint, I can look over his shoulder and make sure he's doing it correctly and vice versa. We can check each other by having a direction. So that's a good example of me just looking over the map and I can visually see that Jet had that in the wrong location. Okay, looks like a big cluster of fixtures, right? So here's something fun. I'm not gonna distract you too much, but let's just draw some lines so that you can see what we're doing. I know you know we're making angles, but what I want to show you is the shape, right? Because we're able to set all these angles, and by touching all the corners of the fixtures, right, we've just created all the angles. Look at that. Is that not cool or what?
That was pretty cool.
Did we pull a protractor out?
No.
You have all your lines there. Do you think that's right?
Sure hope so. That's pretty close.
Pretty close? What are you talking about? It's right on the money. Dead on. This is why I just trust the table. I don't really need a protractor. I trust the CNC grid. Before I came up with this fixture map placement, I had to use tools like this to set up these weird angles and hopefully get them in the right place. So let's just see how good those fixtures are in the long term. So this is a nice big Stabila angle finder. So what we're gonna do, we're gonna put it in here like this. What'd that say? I mean, we're flashing, dancing between 120 and 1.1. We set our fixtures and our stops first.
Yeah.
We haven't even touched your material yet. Now is the time we see if you did a good job cutting it to length and making sure it fits what we actually want. So let's grab your material and let's start placing it in position. And where they go? We need to space the work up off the table.
Yeah.
So we're gonna do the same thing. We're gonna use 1/2-inch spacers all the way around and 2 blocks under each piece of material. Let me give you a couple reasons why we're spacing the work off the table and why it's good practice to do every single time. Sometimes you're gonna run into an instance where you're gonna have a 1-inch tube come into 1.5 inches. This is really common when you're doing pickets or railing, but you can control your elevations with the shims.
Yeah.
The other next thing is that we want the spatter to not hit the table. Remember, we're gonna be doing some welding and we wanna be able to put a plate in there that's gonna protect the table.
Yep.
But you know that already.
All right.
Okay, So go for it. So as Jet's setting up all his work, hopefully in position, let's talk about something here. So designing a fixture map, there's a set of rules that we follow around here. So as Jet's laying his parts into the fixtures, one thing you're gonna notice is that the material is only touching 2 points. Now, why is that necessary? Well, you only need 2 points to create a straight line. And we're gonna use the corners of the fixtures to do that. If you notice, the fixtures don't have a heavy corner radius. They're nice and crisp. By design, this allows us to set the fixtures up this way. Now, if we start turning the fixture, what happens is we lose all the resolution in the holes. We're gonna have a hard time placing the fixture in the correct spot. So it's really hard to identify where the part goes, and that's the whole idea of a map. We need to know where the part goes. Unfortunately, by turning the fixture, you're only gonna be able to get 1 bolt in. And then from here, if we want to set up a backing point to clamp to that runs parallel, we can do that. So let's say if we wanted to put this here, now we can use this fixture and have it float into a hole and clamp to it if we wanted to. Okay, Jet, let's see what you got here. I noticed all the parts are touching the corners of all the pieces, which means they're all in the right location. But now it looks like we have some gaps over here in the corners.
Yep.
So it looks like one of these 2 pieces are too short. It might be okay because we can shift it down a little bit, maybe there. Right, give a little gap because we were tight. Maybe we could shift this in a little bit. That's now weldable. So that was 1/4 of an inch short, and we've given a little gap on all surrounding sides to make it easier to weld. The one thing to notice too, see how your cut angle is wrong?
Yeah.
But that's okay because we're not referencing the cut angle of your tube. Handy, isn't it?
Yeah.
What we're gonna do is, remember, we want at least 2 clamps on every part, and then you know the weld sequence.
Start from the top, down, crotch, out, top, down.
Correct. As Jet's welding the first frame together, I want to explain a little bit more in depth why we weld sequence. Let's talk about that a little bit. The goal of weld sequencing is to limit the movement in the part using the previous weld that we've already done. So we need to start on a joint that doesn't have a lot of leverage to pull the parts out of whack when the weld cools. That's this joint right here, this outside corner. So we start there, and I'm going to represent this weld with a piece of tape. Something like that. Okay, as you can see, the weld's preventing this movement, but what it doesn't do is control the angle. The second joint we're gonna do is this top surface. Now we have to choose, where do we start? Do we start at the point or do we start at the crotch? Well, since this is already welded, we're gonna use this weld to our advantage. It's already holding the distance here at the point, but what we need to do is control here. So we're gonna start here and travel this direction because we know it's not gonna move once we get out here and the weld starts to cool. And as you can see, just with those 2 welds, it's pretty secure. It really doesn't wanna move very much. The next joint is number 3, which should be this backside, but it's not always accessible because you have it on the fixture table. But that's okay. It's pretty secure as it sits. So in this condition, if it's sitting on the table, we're gonna do the fillet weld. Fillet weld is on the inside. It has the most leverage and can do the most damage, so we wanna save that for last. And once we get this one secure, we should have a nice secure joint that doesn't move. Just like that. That should be your weld sequence. You should have a secure joint that's accurate and where you want it. And even with the tape, it's pretty strong. If you're tack welding or full welding, you want to use the same sequence. Tack weld the outside first, come back and tack the center, and then come back and tack the fillet.
Come look at the welds.
All right, Jet, looks like you did a pretty good job. This is what Jet has created so far. It's a 2D side profile of the king post that we're working on. So now what we have are 2 sides. They look like this. And now we have to figure out how to hold them apart, because we have some material that goes in between them that holds them at a set distance. So we have to do a couple of things. We have to be able to hold them like this. We need to hold them like this. We need to hold them like this. We need to hold them like this. There's all these different angles and all these different configurations that these parts can be held into. Now normally we could do this by setting up another fixture over here, welding parts in there, fiddle, 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 or we can use the fixture table. And what we do is we put one side back into the fixture, which it should fit, right, Jet?
Yeah.
The neat thing is we can check his work. It fits real nice back in its home. And now we need to be able to put this one in, but hold it at the right distance of, I think it says 10.5 inches. So we need to be able to hold this side piece just like this. So how are we gonna do that? Because we don't wanna use our material, grab your pieces there. So the thing is, we don't know if you cut these perfect.
Yeah.
Do you think you cut them perfect?
No.
Okay, so we're not gonna use them to set the spacing, right?
Yeah.
We're gonna use the precision drilled holes to set the distance in the fixtures. Okay, so how are we gonna do that? I'll show you. So if we look at the drawing, we need to make a 10-inch shelf.
Okay.
10 inches all the way around. So on the fixture map, we have the shelf set at 10.5 inches. That extra half an inch comes from the shims that we've placed down on the table earlier. So what we can do is set this at 10 inches right there. That gives us a 10-inch shelf all the way around. What we can do is we can replace this with a bolt. Now we got the right length bolt, we can physically just squeeze it to this fixture. So you see how this makes a nice rest for that, which I like, but I want to be able to put a clamp on here to hold it down. So how do we do that? Well, with this cool little mini clamp. Oh, I got a woo out of them. That not super clean, clean. Option number 2, and this is what most other table manufacturers want you to do, is use a 90-degree and a bolt, something like this. Okay, and then you set the distance up, down where you want to go.
Okay.
This is bad because now I have to measure every one and try to dial it into 10 inches. We don't have to do that with this because we got this little guy. This is a miniature tooth block, little teeth that lock it in where we need it on 1/8 of an inch increments. So it works just like the big one. It's just a wee little guy. That's a good option because that tooth right there makes this thing so it won't bump down the slot.
Yeah.
But what we can do now is use a clamp like this.
What I was thinking was just going like this, putting it up like, just like that.
That's the next option. Option number 3. So this is all the opportunities that the Fireball system has for you, right? Like that. And remember all those little short 6-inch risers that you took off of these guys?
Yeah.
We have a whole bunch of them left over.
Yep.
And now we're repurposing them here. We're not losing fixtures, we're just recycling and purposing them in a much better way than having them just sit in the drawer. And the neat thing is they're reversible. I could put it on the back side too. You can go over your fixture on down the bottom. So if it was on the inside, no problem. Pick whatever side you want.
Yep.
The other cool thing, see this one, this is called like a little sidewinder clamp.
Oh, I see.
You can set on here and maybe it's in the way of something, you can bolt it in from the side.
I see.
Which side do you want? Okay. What other options do we got, Jet? We got lots of options. So let's say you wanted to push it backwards. Maybe you wanted this. You could put that in there like that. Not only could you clamp it this way, you could come over here at an angle and push it. So it kind of just moves the holes around.
Yeah.
So many options.
Too many options.
Too many options. No matter what, you don't need to be intimidated, just bring it up to the right elevation. So let's just say this was at the wrong elevation. Like say 10 inches is close, but we needed 10.25. Well, I would then add some shims, like this, right? You got the shim
What if
kit.
it was like 10 3/8?
10 3/8, good question. Pull open the shim kit. 10 3/8, bow. What do you think? Give me another number. You're not making it hard enough for me. Give me another number.
10 11/16.
10 11/16. Oh my goodness, 10 11/16. Okay, so inside this kit, we got it all. You can stack it up in any way you want. So if you wanted to make 11/16, what would you add on to this?
3/16.
3/16. You could do that, which we have right here. 11/16.
What's this one right there? The smallest one.
Smallest one, 1/32.
Goes down that low.
Goes down that low. So that's what I mean. You can hit any dimension you want with this system. And no other table company gives you any of this stuff. They just want you to use that slot. And they want you to adjust all of those slotted fixtures perfect. It's time consuming to do that. So what method are you picking? This one and those little tiny clamps or the little tiny side pushers?
I was thinking about that. Yeah, probably.
So you're gonna get some bolts and you're gonna use the fence blocks. Okay, put all your fixtures in. As Jet's setting up those blocks, let me show you how the other table manufacturers want you to do it. So let's talk about metric fixtures trying to build with imperial measurements. These are metric fixtures. This is 25 millimeters. The distance from this surface to the bottom is metric. Using imperial shims to get imperial measurements, it really doesn't translate very well. A good example of this is I want this bottom and this to be set at 10 inches. No big deal. All right, I could slide this and set the tape measure to 10 inches. lock it down. But what happens if we wanted to use shims in here to rest it on so that we could set several of them up and stack them and have a nice flat reference surface so we don't have to use this goofy slot? Well, look what the measurement is. It's 3 and maybe an 1/8, 3 and a 16th. It's something weird. It's not a nominal dimension from the bottom to the top here. Makes things weird, makes things complicated. You have one bolt, so this thing's gonna pivot on you, potentially, if you don't get the bolt too tight. Hard to adjust because gravity isn't working in our favor. If you use imperial measurements, I recommend getting imperial fixtures. If you use metric, I highly recommend using metric fixtures. It's gonna keep things much easier and it keeps things simpler. The other thing is those fence blocks are 20 bucks. This is $80 bolt and a $80 to $100 fixture. So this is $180, where that setup right here that Jet's doing, this is 20 bucks plus a 50-cent bolt. For all the colleges and everybody that's on a budget, the Fireball system is way more economical. Now, go ahead, bud, drop the top part on top of it. What you think?
Fit right in.
I think it looks dang good. Okay, now what we do is you clamp it. So Jet's gonna use these little side pushers, put in here and clamp down. The neat thing is we have offsets, one for low, one for high, and they're positioned at an angle to kind of push down and back. And if one is in your way, you can pull the foot off and pull the spindle out. Or you can reverse it and push up. Instead of it going down at an angle, you can reverse it and push up if you needed to. So now we need to do the same thing, get a couple more clamps and push down on the bottom.
Okay.
I don't think we need to go quite as crazy as we did the top, but we need to secure it nonetheless.
Don't want to pull the grinder out.
Say no to the grinder, use clamps. Let's get some parts, let's get going. Chop, chop, chop.
I think that's all we need.
Okay, you could weld on this all day and it ain't gonna move probably, is it?
No.
Yeah, that's pretty secure. So this is what we're gonna be using to keep these two side pieces spread apart, just 1 by 1 tube. But what we need to do is put it in between here. And this dimension isn't critical where it goes. It's not really important, there's just a spreader or a gusset. Its only job is to keep these two sides spread apart. So anywhere we wanna put it is fine. So what we like to do is put it in here somewhere where it's easy to weld. I think that's the most important part. We don't want it too close to the edge. We want to move it in a few, about ½ an inch or so. There's several ways to do this and hold this in position up and down. One, we could just put it in here, put a tack, weld it in. Probably don't even need a fixture. It's really not critical. But because we're teaching Jet how to do some of this, we're gonna get a little bit fancy. So here's what I made up. I got a tooth block on a short riser and a little sidewinder clamp. It's creating a little V block right here is the idea. And how this goes is this pin always needs to be on the slot side like this. The balls that lock into the hole need to be in the hole side. So what I've done is I've switched the tooth block around so that we're able to do that. See how the ball is now through the washer. The second bolt, see how we're doing this, Jet? Now we can just shift it in and out.
Yeah.
Whatever it is, we just want it to be the same. We don't really care. That's the cool thing about fabrication. Sometimes you have critical measurements, sometimes you don't. And that's our little fix to put this at a 90. We can weld, at least get a couple tacks in here, and then we can weld around the bottom. This piece of flat bar goes right here on the edge. And what I'm gonna do is we're just gonna clamp it. And you're gonna line it up to the straight edge of the fixture right there. Make sure it's touching there, and then you're gonna weld it. Piece of cake. And these struts are gonna keep these separated at the right distance. As long as all your clamps are tight, which I think you got them, start tacking and welding, and then we'll do an inspection when you're done and see how it turns out, okay? So you're probably wondering why we didn't throw all the components into this fixture and weld it all at once. The first reason is having all the components in there at once limits the weld accessibility, especially the lower section. 2, it's much harder to keep 10 or 12 pieces all lined up than it is 2 individual ones. Third reason is, by building 2 individual side frames, we can isolate some problems and find them early on, instead of having the whole thing completed and then having to cut it apart. Okay, so it looks like you got it welded up. Now let's get it out and we'll check it. Now, the way we set this fixtures up, we set it up in a way to where we could just remove these 3 towers and we can slide it out.
Okay.
And remember, these 3 towers just have these pins in here,
Yeah.
so it's easy to put back into place.
Yeah.
So we can just leave literally everything attached. See how the whole fixture just comes out of the way? And then when you're ready to do the next setup, this just goes right back into position.
That makes my life a lot easier.
It does. That's what fixtures are all about, making lives easier. So in less than 30 seconds, pull these 2 fixtures out and it should slide out. Let's take a look. Look at that. That's pretty cool, huh?
Yeah.
Let's take it out here. Has a little bit of rock to it, but is that because there's a weld in the way? Oh yeah, that's because there's a weld right there. Yeah, let's grind that loose. Do a quick inspection, right? Because this is the most important part about fabricating. It's QCing your own work. It's not bad. A barely little tiny teeter-totter. I mean, that's like nothing. Totally acceptable. In this instance, for this job, this is a skeleton of the post. We're gonna be sheeting it with stuff, and more railing is gonna be tying into the sides. So what I'm really looking for is the tilt back and forth. I want it to sit as plumb and straight as possible, and I want this angle to be correct too, so that all the posts are in a straight line.
Yeah.
We don't want them to be like, some leaning forward, some leaning back. We want it to look just like piano keys, straight. For one, I was gonna use my eyeball just to see if there's anything strange. It looks pretty straight, huh? Should we put a square on it?
Yeah, let's do that.
Okay, Jet, grab one of those big tower blocks right there. This is the 28-inch tower block. I'm just gonna use it to just kind of sight up the side here. Okay, stand it up. Okay, slide it over here to this rail. Dang, good job. Okay, you're like a 32nd of an inch out of plumb. That's pretty good for just having some flat bar on the bottom of this. I think that's gonna work. Do you remember what the overall dimension is supposed to be? What does that say?
42 inches.
Drum roll, editor, please. Did Jetster make it at 42 inches? Oh, I mean, we're splitting hairs. You're 32nd too long. I think that's acceptable. Yeah. Or is it just floating up here a little bit? Can we move the clamp closer? See how this clamp doesn't reach in here? If we wanted to clamp that, go grab me one of those cantilevered clamps over there. I know we're not fixturing anything, but one common problem with these type of table clamps is that they have a hard time getting in between small areas. This is a good example of a tool that solves that. This is a low reach cantilever clamp. You see, we can clamp right in that little crotch right there, and the handle is out here. They're great for stuff like this. Use the right tool for the right job. Now let's measure it. I mean, that's pretty dang close, dude. I mean, less than a 16th.
Yeah.
So we're gonna check Jet's plumb and level because this needs to be parallel to the table. And unfortunately, I've moved my table around a little bit today for filming, and the table isn't level. So we're gonna just use a quick little digital angle finder and zero it to the table like that to kind of do some checks. So look at that, dang near perfect. Pretty good, dude. Let's check up here, about a half a degree off. I think we can live with a half a degree off. Yeah. Okay, let's just check this angle. This is supposed to be 45. Pretty good.
4/10 of a degree.
4/10 of a degree. What's that one?
1/10.
1/10 of a degree. Let's check this one. 105. That's what it's supposed to be. 70. What do you think? Proud of yourself?
Yeah.
Pretty good, young man. So your overall length's really good. Your angles are spot on. This is very tricky.
Yeah.
You did pretty good.
I didn't have very much faith in myself.
You didn't, but now you do.
Yeah.
Nice work.
Let's test it with this.
This win? There's a little overkill. So Jet wants to see how close he came on overall width. Just for fun, this is ridiculous. All right, pretty dang close. 25 thousandths under, not too shabby. I think the fixture table evens the playing field out, doesn't it?
Yeah, it does.
Somebody with your skill level is able to produce something pretty accurate. He's pretty good for a 15-year-old. He's got a bright future ahead of him. This looks great.
Yes.
All right, so we'll finish up the welds around them, grind it smooth, and you got 6 or 7 more of them to build. But now you know what to do and how to do it, and I'm gonna leave you alone. So Jet's done a pretty good job fabricating these posts. The next step we gotta do is put them up there on the balcony. It's It's gonna be pretty fun to see it all come together and see how this 15-year-old's handiwork all fits. If watching me build something here with Jet inspires you to get out in your shop and start fabricating, and you're considering a fixture table of your own, well, I suggest the brand new Fireball Dragon Wagon. This table is set up for a small workshop or entry-level fabricator, and you can grow and expand as your skills improve. I want to see everyone succeed at whatever they're trying to build. And so I invite you all to the Fireball Forum where we can continue the discussion, answer any questions you have, and be the first to see any new Fixture Fundamentals videos. Thank you guys for watching, and I'll see you in the next video.